Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, we're gonna do another question, nine question. So it reads as follows. So we are told that ABC is a tangent, very important. ABC is a tangent to circle BFE, circle BFE. So it is a tangent to this circle, all right? Now, at point B, at this point, so we have a tangent ABC, this tangent here. So that line we are told already it is a tangent. From C, a straight line is drawn parallel to BF. From C, a straight line is drawn parallel to BF. So let me use a different highlight. Let me erase this and do this. So we are told that from C, there is a line. That line, it is parallel to what? That line, it is parallel to BF. Like this. All right. Let me reread it. From C, a straight line is drawn parallel to BF to meet FE. To meet FE produced at D, jalo. EC and BD are drawn. All right. Those are my chords I want to believe. Then I'm told that this angle here, FEB, is equal to BEC, is equal to X. It is given on the diagram, as well as that angle ECD. It is Y. Here is that angle. Now, before I move on, I like using this. I like to say, all right, if I have my parallel lines, I have my parallel lines, all my parallel properties will apply. Now let's see which one might apply. The first one might be this one. I come from F to B, from B to D, like this. Then I know that this angle here should equal to that angle there. All right. Let me collect my data. I haven't looked at the question. I know that angle D2, it is equal to FBD. F angle BD. Why am I saying that alternating angles? I don't know the value as of yet. I'm just collecting my data. Now, another property that I can see, let me remove this so that you can look at all these properties. Another thing, I'll come back to this tangent. Another thing I can see is that if I extended this line ABC here, the property of F applies. Remember, I used to say geometry is fun, like this. Then I used to do it like this, yes. Then we have the F part, you have the U part, you have the N part or the Z part. So in this case, we are looking at F shape. Remember, your F shape can look like this, can look like this. However, all right. So I'm saying to this case, if I have this, therefore I know this angle here, angle B1, is gonna be equal to this whole angle here. We agree? We all agree? Yes. Now I'm coming back and saying another second point I have seen is that angle B1, it is equal to angle DCB. D angle CB or B angle CD, however, this is written. It is equal to B angle CD. This angle, this, you can see again. You can say as, all right, we'll see that. We'll see that. Then, why are we saying that? Remember the reason for F shape, it is what? Corresponding angles. You should not forget to include which lines are parallel. Which lines are parallel? BF is parallel to CD for both. Even here, it applies. But don't worry, we will write it formally. I feel like this is too small. Let me see which one I was using here. Yes. All right. Now the third one maybe that I might see, or all right, I'm done. I think I'm done with the parallel lines. I think I'm done with the parallel lines for now. We can also use this part that says we know that these two angles here and here, the sum of them it is equal to 180 again, but they really like that one. And now let's move away from parallel lines. Let's come back to a tangent. Here we have our tangent. So if I have my tangent there, my tangent ABC, remember the properties of a tangent. It is saying if I have a radius, it's going to be perpendicular, but in this case I do not have any radius. Okay, so it means another one that includes a tangent, it is a what? A tan chord theorem. So I'm having a tangent and a chord BF here, chord BF. All right, now I'm told according to the theorem that an angle between a tangent and a chord, this angle between a tangent and a chord, it is equal to an angle subtended by that chord. I repeat, the angle subtended a by a tangent and a chord. Here is my tangent, here is my chord. All right, the angle that is subtended by that, it is equal to an angle subtended by that chord. Which chord? Chord BF. They meet where inside the circle. B goes to E. B goes to E like this. Then F goes to E. So they meet at E. So it means it is equal to that angle subtended by that chord. Which angle is that? This one. So I can collect my data again and say, now angle B1, it is equal to angle EX. Angle FEB. FEB. Angle FEB, which it is equal to X. Why am I saying that? The reason for this one, it is what? Tan chord theorem. All right. Another thing that I can use with a tangent, well, I might have tangent from the common point, but in this case, there is no other tangent. Do not say EC, it is a tangent. You were not told that EC is a tangent. So if EC, you were not told that it is a tangent, you cannot use that tangent from the common point and say, therefore, these angles here are equal. No. You do not use that. You have to be told first. I think the information that's important that I was given, I used it. So now let's answer the questions. Now they say to us, calculate in terms of x and y, the size of the following angles. A angle BF. Now, before I can recalculate anything, I come back to my information and see if I haven't calculated A angle BF now. So I can see, all right, I did not calculate any A angle BF from the information that I calculated here. So I look at A angle BF. A angle BF. Well, if I look very well, A angle BF, it is the same as this is angle B1. All right? When I located A angle BF, this is the angle that you're looking about, which is what? Angle B1. You can write it easier for you so that you can see. But remember, we have already found angle B1. So this is very straightforward. I just come here and say that angle, it is equal to how much? It is equal to X. I do not care it is equal to what. I know it is equal to X. Why am I saying it is equal to X? My reasoning, it is tan chord theorem. I'm done. One information that I collected gone. Correct. Easy 2 marks. Statement it is equal to x. You do not need to say it is equal to. Alright, you might say it is equal to FEB like this, then it is equal to x, but either way, it is still the same thing. Alright? Then statement and reason. Now let's look at the other one, BCD. BCD, we look at our information. Did we calculate BCD? Yes, we did. So this is very nice. We said BCD, it is equal to angle B. Just angle B. This is weird. There's no way it's going to be just angle B. Let's see. We used corresponding angles. So it is angle B1 here. We all agree because corresponding angles, if I remember very well, was this part. Was this part. So I was talking about B1 and BCD. So here it was supposed to be B1. And I have already calculated that one, hore, B angle CD. B angle CD, it is equal to B1. So I'm gonna say angle, it is equal to angle B1. And angle B1, Leona, I know it is equal to angle X. So what is my reason? Why? Already I know angle B1, hence I am saying now it is equal to X, because angle B1 was already proven that it is equal to X. Again, from this point here. So I'm going to say, what is my reason in this case? My reason, it is what? Corresponding angles. But such that what? Such that BF, it is parallel to CD. Another information that is important was used. Now, let me just add whatever information that I have. I know this is X. Which other angle again? This whole part. This X. BCD. Yes, it is X. In terms of X and Y, I did not see any Y coming into play here. Let me see. Maybe there is something that I'm missing. Y. In terms of ABF, I know it is equal to X, correct? Then this. All right. Well, it is C1 plus Y, but it is X. All right. It's fine. Now, we are asked, why is BECD? Why is BECD a cyclic quadrilateral? BECD, let's locate that. CD. So probably they are talking about this thing here. And we are asked, why is it a cyclic quadrilateral? Remember, there are ways of saying something it is a quadrilateral again. So the first one, it is saying a exterior angle, it is equal to, let me do this, exterior angle, it is equal to interior angle. The other one is saying this and this are equal, bow tie. The third one is saying this and this are equal to 180. So, but when I see here, I have drawn BECD. BEDC. So I can see something here, if you can see it with me. Do you all agree that I can see a bow tie somehow inside the shape there? Remember, from the statement that I was given, I couldn't conclude that this is a bow tie. Why? Because I was not given that it is a cyclic quad again. But you can, but I opted against it. So I know if that's the case, this angle here is going to be equal to this angle here, right? Or this angle here, it is going to be equal to this angle here. So if we can find a way of proving that, or rather, we should give a reason rather why BECD, it is a what? it is a cyclic quad. Let's see. Any property that can work. Yes. All right. I can see the bow tie does not work here because this we do not know D2. Well, we do know D2. We can get D2 and say D2 is equal to FBD. But FBD, which FBD are we talking about? FBD. But FBD has no, its angle is unknown, as well as D2 its angle is unknown. Again, so I'm moving away from that. Now let's see. B3 it is equal to Y. Have we proven anywhere that B3 it is equal to Y? No, we haven't. All right. So we are running away from our bow tie. All right. I'm looking at another property. I know all of this actually. All of this, it is equal to X. So I'm looking at another property. I'm done with the bow tie. It did not work. I'm moving to another property that says whatever. It should be straight. If I'm having a quadrilateral, this angle should be equal to the interior opposite angle. So let me see any angle that has a thingy. So I can use this one. Why? Because I know its angle here. Let me remove this so that you can see. I want you to see that. All right. This is X. We all agree, so that I make it more visible. This is X. So why am I using this one as an exterior? Because I know this exterior angle. Okay? So I might try to find to see if it is equal to the interior opposite angle. And in this case, yes, it's true. If I'm talking about this angle, I'm going to look at the interior opposite angle of it. And I can see, okay, my exterior angle here, it is X, as well as my interior opposite angle, it is X. Therefore, it means should be a cyclic quad. This should be a cyclic quad. Why? I'm going to say converse. Remember, I'm trying to prove converse what? What did we use here? Exterior angle of a cyclic quad. Remember, if you cyclic quad, you can say cyclic quad. All right? This is an exterior angle of a cyclic quad. All right? If you opt against saying converse, exterior angle of a cyclic quad, you can say exterior angle of a cyclic quad, it is equal to the interior opposite angle of a quadrilateral, which is long. But in this case, you can say converse, exterior angle of a cyclic quad. Again, remember we are using converse if you are trying to prove something. But if we were already told that this is a cyclic quad, we could have said this, it is equal to this, and used exterior angle of a cyclic quad. But in this case, we were not given that it is a cyclic quad. Hence, we use what? Converse. Then let's move on. I believe these things that I'm doing here are very, very important of you. Now, this one I'm going to remove because I already used. But this one I haven't used. This one. Oh, this one I have already used. But this one I haven't used. So I'm going to keep until I'm done with the question. So the question says, which two other angles are equal to X? Give reasons for your answer. Before I go anywhere, I just want to see something. Remember, I have already proven this is a cyclic quad. Okay? So if I have proven this is a cyclic quad, it means this theorem can now come into play. This one. That says this is my bow tie shape. This one. You all agree? I can now do it nicely. I can just conclude nicely because I have already proven that this one, it is a what? Sorry, it is a cyclic quad. So I can now say this, it is equal to that. Again, I can say now D2 it is equal to X. Why am I saying D2 it is equal to X? I can say, let me remove this. I can easily say angle angle D2, it is equal to x. Why am I saying that? Remember bow tie shape. How do I reason for a bow tie shape? Angles in the same segment. All right, but now that D2 I already classified as x here due to that reasoning there. If I know this is x, if I know this is x, I know I haven't used this one and I might need it because it has something to do with what? With a D2. So now I can say D2 it is equal to FBD, or FBD it is equal to D2 it is equal to x, because now which FBD are we talking about? FBD. Yes, this one. Let me redo that. FBD. So I'm saying this angle FBD it is equal to x, which is equal to D2 again. So I'm gonna use that one again. I'm gonna say now F angle BD it is equal to angle D2 it is equal to x. Why am I saying that? Alternating angles such that which two lines BF it is parallel to CD. You see the importance of noting down your data. You see the importance from these lines. I was given a tangent and I used a tangent somewhere somehow. I was given parallel lines and I used parallel lines. You see, each and every information that you are given that is important, that you should see. The examiner will never give you just for fun. That information that the examiner has given you, you will use it. You will use it. Thank you very much, folks, for today. I think that's all. Until we meet again on the next video. Thank you very much, folks.